Alright, so this video is going to be on graphing tangent functions, and it'll be my first of two. So this one's just going to be on the basics and some basic transformations, and then the next one we'll talk about period changes and horizontal shifts. So let's just first make a table of what a tangent function would look like. So we'll make a table of points, and then from there we should be okay. But if you know your trig tables or your unit circle, hopefully you can do this with me. The tangent of negative pi halves would be undefined. Okay. The tangent of negative pi fourths, that would be in the fourth quadrant where tangent is negative, that would be -1. The tangent of 0 is 0. The tangent of pi fourths in the first quadrant is 1. And the tangent of pi halves is undefined. Hopefully you know why they're undefined. They're undefined because if you look at the unit circle, right, negative pi halves is down here on the unit circle. That's 0, -1. And tangent is done by doing y, the -1, divided by x. So y divided by x would be undefined, right, because you can't divide by 0. And then pi halves would also be undefined when we do the tangent, because this is 0, 1. And so once again, y divided by x, 1 divided by 0 would be undefined. So what happens on a tangent graph when you get to values where you can't actually take the tangent of those, where it's undefined? What we're going to get is we're going to get vertical asymptotes, okay? So just kind of like a rational function where when you can't divide by 0, you get, oh, I just started writing the word rational, look at that. We're going to get vertical asymptotes because on rational functions, when you can't divide by 0, usually those are vertical asymptotes. All right, so that's where we're going to have vertical asymptotes. Also notice something else about this, right? From negative pi halves to pi halves, if you can picture that, that's one full period. So the period of a tangent function isn't 2 pi like sine and cosine, but it's pi. And so we're going to graph this, and then maybe we'll graph one more period. But let's get going here. So we have, let's pick a different color. Right, so we have negative pi fourths and negative pi halves. What the? Sorry about that. So there's negative pi fourths, and then pi fourths and pi halves. And then when you're graphing a tangent function, the start and the end are going to be asymptotes, like we just talked about. So I'm going to draw in some dotted lines, right? And these are going to represent my vertical asymptotes. And then I'm going to plot the points. And the points are 0, 0. And then pi fourths is at 1, +1. And then negative pi fourths is at -1. And the graph's going to look like this. Okay? And then we could do another period if we wanted, right? So we could count out, so we just add the period, so that'd be pi halves plus pi, and that would be 3 pi halves. And if you notice, that would end up here, and the notches are going by pi fourths. So once again, you could take maybe, if you look over to the left, if you take your period and divide it by 4, pi divided by 4 would be pi fourths. And so the next one, right, would be 3 pi fourths, and then pi, and then 5 pi fourths, right, 3 pi fourths. And so that would be all the x values that you could use for the first two periods if you wanted, or you could go to the left if you wanted, but either way, right? And then we're going to plot those points always in the middle, and it'll just repeat itself since it's a periodic function. As you go from period to period, the graph won't change, right? And instead, that's what we'll have. Now, the next thing that I should probably talk about is what do you do in reference to the domain and the range. So when you look at this, hopefully you would agree with me that the domain can't be all real numbers, because since we have vertical asymptotes, then the domain has values that x can't equal. The range, however, The range, however, is all real numbers, and the graph is going all the way up and all the way down. So it's using all the y values, right? All real numbers for y values, but not for x. So what we do, or at least what I teach my students to do, is I encourage them to write an equation for the asymptotes. So we're going to write an equation that's going to describe, right? That's going to describe the asymptotes. Because if you keep going, right, count out 1, 2, 3, and then right there we'll have another asymptote, and then we'll make a curve, right? I'm not going to do it, but 1, 2, 3, and then make another one. If I kept going to the left, I would have asymptotes and all the way to the left forever, and then I would keep getting more asymptotes to the right if you kept going all the way to the right forever. We've just graphed 2 periods, but there's an infinite number, and so there's an infinite number of asymptotes. The question that you need to do is think about how far apart are they, right? So if you start noticing the asymptotes are spaced apart, well, that was bad bracket. The asymptotes are spaced apart by the period, pi. And so since the asymptotes are spaced apart by the period pi, we can kind of write a formula for this. So it's going to look like this. X equals is how we write a vertical asymptote. And then I'm going to pick an asymptote, so I'll pick pi halves. So pi halves. And then plus, okay, pi halves plus, and then the spacing of it is pi. So we're going to say pi halves plus pi, and then n. I'm going to say that n is an integer. Any integer. Hopefully you know what an integer is. If you're one of my students, you better know what an integer is. An integer is a whole number, or their opposites, right? So no decimals, no fractions, things like that. Just whole numbers and their opposites. So if you think about it, pick an integer for n, like 2. Then you would have pi halves plus 2 pi, and that would be 5 pi halves. So it would be 2 periods away. So here's pi halves, and then you'd be going 1, 2 periods away. So this one right here is what you'd be talking about. And so it's a way of showing, right? It's a way of showing all the asymptotes without actually listing all the asymptotes, because you can't. Sometimes people use k as the variable. That's also good. And so the way you would write the domain then is you would say x can't equal these things. And so x can't equal pi halves, right, plus pi n. And so therefore you have the domain represented by what x can't equal, and it's that description of the asymptotes. All right, but that's tangent in its most basic form. All right, we'll just do a couple examples so that hopefully you can kind of feel good about it. The graphing form is very similar to everything else. Cotangent, sine, cosine, they all have the same graphing form. That's going to still do our vertical shift. And this one's going to talk about the amplitude, but it's really a vertical stretch or shrink. And I'll show you where A shows up in the graph. I'll go back up and I'll show you. So in our graph, it was just tangent of x. So if you wanted to look up here, you could see that there's like a 1 in front of there. So then where would that show up on the graph if you're looking at the graph? Right, it would show up right here. That's your deal right there. So the A value would just be how high it goes up to the right and how low it goes down to the left. And that would be your A value. So if it's 3 tangent of x, then it would go up 3 to the right and down 3 to the left. So that's all the A is going to do. It's not quite the amplitude, since it's not really the highest part that it goes up and the lowest. We'll save these two for the next video. All right, so let's get to it. We've got y equals 4 plus 2 tangent of x. So if I ask you what the A value is, right, when we break it down, we would say that the A value is 2. If I say what's the period, right, it doesn't seem like there's a period change, so the period's pi of a tangent function, and then there's a vertical shift happening, and so the vertical shift is going to be up 4. Okay, so as I've done in my other videos, you know, if you're thinking about where the graph starts and ends, it's not got any different period here. So a tangent function always starts at negative pi halves unless it's been shifted or there's a different period. And then going to start at end at positive pi halves. Then the notches go by pi fourths. So this in the middle of those two would definitely be 0, and then negative pi fourths and pi fourths. And that's the basic breakdown of the x-axis when we're doing tangent, all right? And so if we want, we can maybe just put those here, 1, 2, 1, 2, and we'll just label it down here, negative pi halves, negative pi fourths, and pi halves. All right? Then I would encourage you to draw in the midline, right? Draw in the midline, and that's going to be your vertical shift. So wherever your vertical shift is, which is up 4, that's what we're going to draw in. We're going to draw in up 4, so 1, 2, 3, 4. And then draw in just with a dotted line. There that is. Okay, also don't forget tangent starts and ends with asymptotes. So we're going to also draw in some dotted lines with asymptotes as well. Our vertical asymptotes. And then the way I tell people to graph it is you should always put a point in the middle on the midline. So right there at 0, instead of being at 0, 0, it's going to be shifted up to 0, 4, right? So it'll be right in the middle, and then the amplitude, this 2 right here, is going to go up 2 to the right. That's our vertical stretch, and down 2 to the left. And then do your best to make what looks like a cubic function. And there's one period of a tangent function. And then to make more, you could just go to the right or to the left another period. So the period's pi. So I could take pi plus pi halves, and I would get 3 pi halves. So 1, 2, 3, 4. That'd be 3 pi halves. And then we could do it all over again, right? So labeling your x-axis and plotting the points. Okay. This would be 3 pi fourths. Since we go by fourths, 4 fourths would just be pi, and then another fourth would be 5 pi fourths. All right. Then if you're going to do the domain and range, remember the domain requires that you write an equation for the asymptote. So once again, you're going to pick an asymptote. So it'll be x pi halves plus the period. So the period's still pi. Right? The asymptotes are spaced out by the period, plus pi, and where n is an integer, and we're going to say x can't equal that. And then the range is going to be all real numbers. Okay? So in this moment, if that all makes sense, great. What you can do is you can hit pause here, and you can try to actually do this one. Hit pause, and then start it back up, and kind of fast forward it a little bit if you want. Watch it at ×2, ×10, whatever you want to do. But watch it and then see if you get it right. If you need to see it again, stay tuned. Here we go. All right. So I'm going to say that A is 3, but I'm going to remind myself that I need to reflect this. Okay? Then my period is still pi, and my vertical shift is up 1. Since the period doesn't change, I already know that my axes are going to be the same, right? So we're going to have, it's going to start at negative pi halves, and then negative pi fourths. I'll use 0, pi fourths, pi halves, 3 pi fourths, 4 fourths, which is pi, 5 fourths, and 6 fourths, which is 3 pi halves. And that's 2 full periods. I do 2 just because that's what I ask my students to do. So here's my vertical asymptote. Starts at negative pi halves. I have another one where the first period ends at pi halves. Then I have another one where the second period ends at 3 pi halves. We're going to draw our horizontal shift or vertical shift. All right, there we have it. And then now we're going to plot the graph. Since there's a reflection, instead of going up to the right and down to the left, we're actually going to reflect it over the x-axis, and it'll go more in that direction, up to the left and down to the right. So we'll put a point at the middle, then we'll go up 3 to the left, down 3 to the right, then we'll go to the middle, up 3 to the left, down 3 to the right. And do your best to make a nice curve. And there's 2 full periods. Since the period and there's no horizontal shift, the period doesn't change, no horizontal shift, the domain is the same as the one above. You can take a look at it, right? You have an asymptote at pi halves, so x can't equal pi halves plus pi n, since they are spaced out by just pi. And then your range, once again, is all real numbers. Okay? Hopefully that makes sense. Best of luck to you. Have a great day.